Dear students, in this class, I wish to clarify a few more points about well-behaved preferences. Well-behaved preferences. As we have discussed in the previous class, it is possible to formulate the theory of consumer choice. The theory of consumer choice in terms of consumer preferences. Consumer preferences satisfying the axioms of completeness and transitivity. And if these assumptions are satisfied, these axioms are satisfied, we have specified the indifference curves associated with these preferences. That is the graphical representation of consumer preferences. Consumer preferences. And we have also discussed the shape of indifference curves associated with the specific preferences. So, our aim is to determine the choice of the bundle. The choice partly depends on preferences. Preferences, if two bundles X and Y are given, we assume that the consumer strictly prefers bundle X to Y, weakly prefers X to Y, indifferent between X to Y, etc. Also, his preferences satisfy the axioms of completeness and transitivity. We assume that he is able to rank all the bundles, completeness. Transitivity also we have discussed. So, from the preferences, we can infer about the choice of the consumer. But a more convenient way to represent preferences and hence choice is using a graphical device, and this graphical device is the indifference curve. But if we want to describe preferences in general, it is more convenient to focus on some of the general shapes of indifference curves. Some of the general shapes. And to specify these general shapes, we have to make a few more assumptions about preferences, that is, in addition to completeness and transitivities, and also the implication of these assumptions about the shape of the indifference curves. And these assumptions, the two assumptions which we have discussed earlier, plus two more assumptions which we are going to discuss, define well-behaved indifference curves. Well-behaved indifference curves. Well-behaved indifference curves or well-behaved preferences. The first assumption or axiom is more is better. That is, we are talking about the goods, not bads. All goods are good, no good is a bad. So, if X1, Y1 is a bundle, X2, Y2 is another bundle, we will call X1, Y1 is one bundle, X2, Y2 is another bundle. And if this bundle contain, what to say, at least one as much of both or more of one, then X2, Y2 is referred to X1, Y1. x1, y1. Suppose that this is x1, x2, x1, y is 10, 10, x2, y2 is 10 and 15. As this contain same x and more of y, this is preferred to this. And this assumption technically is known as monotonicity of preferences. Monotonicity. This assumption is technically known as monotonicity of preferences. And remember this axiom holds, as we have discussed earlier, only up to the point where the consumer reaches satiation, the point of bliss. And remember this, we are not interested in points of bliss where everyone will get everything else. So, this axiom generally holds as we are discussing cases in which consumer is not supplied with everything he desires. Now, what is the monotonicity imply for the shape of the indifference curve? It implies that indifference curve has a negative slope. X, y, you consider a bundle, say x1, y1, you consider any bundle x1, y1, then these are better bundles compared to x1, y1. These are better bundles and these are worse bundles. And indifference curve is negatively sloped. If you move up and right, preferred bundles. If you move down and left, worse position. If moving to indifferent positions, we must be moving either left and up or right and down, indifferent positions. So, this axiom monotonicity has an implication for the shape of the indifference curve, that indifference curve is negatively sloped. The second axiom is, we assume that averages are preferred to extremes. If x1, x2, if x1, y1 and x2, y2 are any two bundles, so in the form of an indifference curve, suppose this is say y1, x1, then this is y2, x2. Then this is A, this is B, this we have discussed earlier. Then you consider an average, that is x1 plus x2 by 2 and y1 plus y2 by 2, point C, average of the original bundle x1, y1, x2, y2. So, if we take a weighted average of the bundles A and B, that is x1, y1 and x2, y2, then the average bundle is at least as good as or strictly preferred to. At least as good as or strictly preferred to. Remember this, at least as good as or strictly prefers to means at least as good as or strictly prefers, preferred to or indifferent to the original combinations x1, y1, x2, y2. Now, this is true for any weight t between 0, any weight t between 0 and 1. It is not necessary that the weight is 1 by 2. This is applicable to any average. And suppose that the consumer is indifferent between x1, y1, x2, y2. Then you consider an average tx1 plus 1 minus t y1, then tx2 plus 1 minus t y2 with a different weight t and 1 minus t. Again, this bundle is preferred to the original bundle x1 y1 x2 y2. And geometrically, this assumption about preferences means that set of bundles weakly preferred to x1 x2, set of bundles weakly preferred to any bundle y1 x1 or y2 x2 is a convex set. And the convex set has the property that if you take any points in the set and if you draw line segments connecting these points, the segment lie entirely in the set. The segments lie entirely in the set. Consider x1, y1. Consider any 2 points. Then you connect point A and B with a line. The line is contained entirely within the set. So it is a convex set. All the sets need not be convex. There are also sets which are not convex. And what to say? An extension of the assumption of convexity is strict convexity. It means that the weighted average is strictly preferred to x bundle or strictly preferred to the initial bundles x1, y1, x2, y2. Strictly preferred, not only weakly preferred, strictly preferred. Convex preferences may have flat spots, but strict convexity means indifference curves are rounded. And indifference curve for perfect substitutes, as an example, is convex, not strictly convex. So, this averages are preferred to extremes geometrically means strict convexity of indifference curves. Strict convexity of indifference curves. So, these are the points which we have discussed already, and it is only a repetition to clarify some points.